Welcome to the DIY Honda Garage channel. Welcome to the diagnostic guide for DTC P0137, which pertains to the secondary heated oxygen sensor, secondary HO2S, circuit experiencing low voltage issues. This DTC indicates that the output voltage from the secondary HO2S is below specified thresholds, thus prompting the powertrain control module, PCM, to store this diagnostic trouble code. The secondary HO2S plays a crucial role in monitoring the efficiency of the catalytic converter by measuring the oxygen levels in the exhaust gases. Typically, this sensor is located in the exhaust system downstream of the catalytic converter, positioned to ensure accurate readings post-filtration. The significance of the secondary HO2S lies in its ability to help optimize fuel efficiency and minimize emissions. In the 2023 Honda CR-V, understanding the intricacies of this code and its components is essential for effective troubleshooting and repair. DTC P0137 specifically refers to the secondary heated oxygen sensor, commonly referred to as secondary HO2S or sensor 2. This sensor's main function is to gauge the amount of oxygen in the exhaust gases after they have passed through the catalytic converter, which provides crucial feedback for the PCM to adjust air-fuel mixtures. The term output voltage low indicates that the voltage signal from this sensor has dipped below a set benchmark, signaling to the PCM that something may be amiss in the sensor itself or the surrounding circuitry. In Honda CR-V 2023 models, this sensor is typically located in the exhaust system downstream, making it challenging to access without proper equipment. Understanding the role and placement of the secondary HO2S is vital for diagnosing the system accurately, as this component directly impacts engine performance and emission controls. Several potential causes can lead to the occurrence of DTC P0137. The faulty secondary heated oxygen sensor itself. Wear and tear or damage can deter its effectiveness. The external circuit might be compromised as well, which could include shorted wires or poor connections, reducing the sensor's ability to transmit accurate readings. Additionally, a malfunctioning powertrain control module, PCM, may misinterpret sensor signals, leading to incorrect data being stored. Each of these causes needs thorough inspection, as they contribute significantly to the overall health of the emission control system. Proper identification of these issues is critical to ensure the accurate functionality of the engine management system, aiding in compliance with emission standards and optimizing engine performance. The symptoms associated with DTC P0137 can significantly affect vehicle performance and driver experience. One of the most noticeable signs is the illumination of the check engine light, which is the vehicle's way of alerting drivers to potential issues. Alongside this warning, drivers may experience poor fuel efficiency, as the engine may struggle to achieve optimal combustion due to erroneous sensor readings. Furthermore, elevated emissions levels can occur, producing harmful pollutants that exceed standard limits. This situation not only impacts the environment, but could also lead to failure in emissions testing. Recognizing these symptoms early is vital for prompt diagnosis and can prevent further issues arising from neglecting this warning signal. The first step in addressing DTC P0137 involves starting the engine and maintaining the engine speed at 3,000 RPM without a load. This procedure allows the vehicle's systems to reach operational conditions where emission components are functional. Holding the engine at this speed until the radiator fan activates ensures that the engine is hot and the exhaust gases are flowing. During this time, it is essential to monitor the Honda Diagnostic System, HDS, for the presence of DTC P0137. If the code is present, It confirms that the secondary HO2S is indeed signaling low voltage, and further steps in the troubleshooting process would be necessary. This method is vital in establishing a baseline of operational data before conducting more intrusive tests. In the second troubleshooting step, the focus shifts to the secondary HO2S sensor 2. First, you need to disconnect the sensor connector to isolate it from the circuit before conducting the tests. Then, turning the vehicle to the on mode while leaving the engine off enables the HDS to be activated without extraneous factors influencing the readings. It is critical at this stage to confirm whether the HDS HO2S S2 value is above 0.17 volts. If the readings are as expected, it indicates that the circuit is likely functioning correctly, and the issue may lie with the sensor itself. Conversely, if abnormalities are detected in the readings, further investigation into other components involved in the system would be necessary. Understanding these thresholds is vital for effective troubleshooting. The third step involves focusing on potential issues within the wiring and circuit integrity. Preparations include ensuring the PCM connector and the secondary HO2S sensor 2 connector are both disconnected. Prior to beginning inspections, jumping the SCS service check flag line with the HDS is a crucial precautionary measure to prevent any short circuits, allowing for a proper evaluation. It's important to wait for more than 1 minute post-jump to stabilize the system before proceeding. The next action involves meticulously inspecting the wiring for any shorts or disconnections according to the open-shorted wire inspection description provided in the manual. If abnormal conditions are found, such as short circuits to ground or disrupted signal paths, those need to be addressed immediately to prevent further issues down the line. The final step in troubleshooting DTC P0137 concentrates on the PCM, or Powertrain Control Module. If prior inspection tasks indicated that all components behaved within normal parameters, it's likely that the PCM itself is malfunctioning. This module serves as the brain of the engine management system, interpreting data from the sensors to make adjustments for optimal performance. Properly diagnosing the PCM requires specialized tools and knowledge about the vehicle's internal systems. If it is determined that the PCM is at fault, replacement or reprogramming may be required to restore proper functionality. Not addressing these potential PCM issues could result in persistent fault codes and reduced vehicle performance. After completing the necessary repairs or component replacements associated with DTC P0137, the final verification step is critical. Start by clearing the DTC using the HDS to ensure that it is no longer stored in the system. Following this, conduct a test drive of the vehicle under various conditions to ensure all systems are functioning appropriately. While driving, pay close attention to the performance and responsiveness of the engine, in addition to any dashboard alerts. After the test drive, once again check the HDS for any reappearance of DTC P0137 or other related codes. If the code does not return, then the repairs have been successful. However, keep in mind that consistent monitoring post-repair is essential to assure the long-term reliability of the vehicle's emission system. To prevent DTC P0137 from reoccurring, establishing a routine preventive maintenance schedule is key. Regular checks of the secondary HO2S and associated wiring can help catch issues before they escalate. It's essential also to monitor fuel quality, as poor quality fuel can lead to premature degradation of emission components, subsequently affecting the HO2S performance. Moreover, performing periodic system diagnostics with the HDS can help ensure that all components are functioning correctly within the engine management system. Taking preemptive actions like these will contribute to improved overall vehicle health, enhanced fuel efficiency, and lowered emissions. Consistency in maintenance not only improves performance, but extends the lifespan of valuable components as well. In summary, DTC P0137 signals a lower than expected voltage from the secondary heated oxygen sensor, indicating potential issues within the sensor or related circuitry. Addressing this code involves a series of methodical troubleshooting steps, from initial diagnostics through component examinations to evaluating the PCM. Recognizing the symptoms and understanding the root causes are crucial strategies to ensure optimal performance of the Honda CR-V's emission control systems. Furthermore, the emphasis on preventive maintenance will provide reassurance against future occurrences of such diagnostic trouble codes. By adhering to the outlined procedures and maintenance practices, vehicle owners can maintain performance and comply with emission standards, ultimately enhancing the driving experience. Please like and subscribe to the channel. See you next time.